Okay, let's. All right, let's talk about business. So for Tuesday, you've got the assignment will appear later this morning. This is it though. Selected parts of the next two sections. Okay, so read really carefully. I'm not asking you to read everything and answer every question in these two. It's selected parts of each. Okay, so this will be a little bit shorter than last weekend's homework because our first exam is Wednesday night, and you really should start digging in for your studying this weekend. Do not wait till Tuesday to start studying. Okay, start studying this weekend. Okay, so you got a little bit for Module 2, Section 2, part of Module 2, Section 3, which are both posted, and then start studying. So I've opened up a new area on Blackboard called Exam Prep and Solutions. I just want to center this. Okay, this is a new area here. Exam Prep and Solutions. It's your new best friend. Okay? Here is a bullet point outline of what is covered on the exam. So there's no questions on the exam that aren't under the umbrella of one of these bullet points. Okay? So that's like just a concept outline. And then here's solutions for all of the modules, or for all the sections in Module 1, except the graphing calculator stuff, which you should be able to check on your own using graphing calculator. And then I'll post, after we hand in the homework Tuesday, right away, I'll post some Module 2 homework solutions. Actually, we're turning in all Module Section 1 today, so I'll be posting Module 2 solutions as appropriate, and then the quiz, a solutions version and a blank version. That's quiz number 1. And then again, after all the people who haven't taken the quiz have taken it, I'll post the same thing for this quiz number 2 today. Okay, so you have full solutions. You'll have, by the time Monday or Tuesday comes around, you'll have full solutions for all the homework and both quizzes, and then you've got this bullet point outline. So, how do you study for the test? Make sure, so go through each thing, know what these bullets are talking about, and then try the problems again. So problems that you did 2 weeks ago, you're not going to remember. Try them again, and then use the solutions as a reference. Don't start your studying by looking at the solutions. Don't just pull the solutions out and just read the solutions and go, yeah, I get that, and just read along. That's not good studying, because you had to be able to have a problem that you don't know the solution to and take the initiative to proceed correctly, figure things out. So solutions should be a reference, not a starting point of your studying. Does that make sense? Okay. Questions about the exam? Oh, and so then some of you have conflicts. You have another exam or you have class on Wednesday night. Tomorrow I will send out an email with soliciting those of you who have that situation. You're going to email me back, and I'm going to give you once you email me back, I'll give you details about alternative arrangements for taking exam 1 instead of Wednesday night. Yes, sir?
We are allowed to show up at 7:30.
It depends. So if you know that you take a lot of time on exams and you need more time, that's your nature, then maybe you feel too pressured starting that late. So it's just kind of up to you. For some, you're good, efficient test takers, you do it pretty quickly. Coming at 7:30 will be enough time. But others, it may not be. So we'll do that case-by-case basis. You can talk to me. Yes, sir?
What's the earliest time we can come?
what did I say? 6:30 or 6:30?
6:30 p.m.
6:30 is the starting time.
Okay.
And we have, you have till 9, but this first exam, no one's going to be there that late, okay? So plan on, if you start around 6:30, an hour to an hour and a half, probably at the most for most people. Hour and a half will be only a few of you, okay? Most of you around an hour 15.
How many questions are you talking
Around 25. Around 25 questions. Yeah.
about? Is it in this room?
No, it's we're going to be in the testing center, PSA 21. PSA 21 at 6:30 p.m. Wednesday night. I'll review that on Tuesday. PSA 21 is at the corner of Palm Walk and Tyler Mall. It's like a minute away from here.
Where the recitations are.
Yeah, where your recitation, in that same building where your recitation is, just down. Are you on second floor or first floor?
Basement.
I know, the recitations.
First one.
They're on the first floor.
So you're just one floor below your recitation. Just go down one floor, room 21. Room 21, 6:30 p.m. Wednesday.
East and down. We're in the separate east and then down.
I'll figure it out.
Yeah.
Any other questions about exam or homework? Okay, so the material covered on the exam includes today. Okay, so today is the last day, and today's homework that's due Tuesday. So what we cover today and what's due on Tuesday is on the exam. What we do on Tuesday may draw on a lot of that, but any new material on Tuesday won't be on the exam. But not to say, so everything's building on each other, as you see. Everything builds on what we've done before. So stuff that we talk about Tuesday, lots of it may pertain to the exam, but what's new on Tuesday won't. Any other questions? Okay, so I feel like there's something else to say. Hopefully I'll think of it. Okay, so we're talking about constant rate of change. This whole part of the course right now, here's my experience with this whole part of the course. We get into the middle of the course, and we're in the trenches of the calculus, and these kinds of concepts are showing up, and it's like students, a lot of students, it's like we never did it. It's like we never did it. Try as hard as you can to learn this, retain it, and then be on the lookout to apply it when somebody isn't holding your hand and asking you questions to apply it. Okay, so all this stuff shows up more indirectly in all the stuff we're going to do, and so it has to be at your fingertips. It has to be a tool in your tool belt that you know when to pull out and use. So this stuff about function notation, interpreting graphs, the output of the function is the y coordinate, constant rate of change. This is all crucial stuff. It's got to be in there, and it's got to be at the ready. You got to have it at your fingertips, ready to use. Okay? So here we go. Here's a situation. We got two painters have started painting their respective houses. At a certain point, first painter has already painted 250 square feet, and the second painter has already painted 400 square feet. Okay, so history has proven that students who attend to the quantities, who define variables and attend to the quantities and situations, are the ones who succeed. So the first thing we want to do always is define variables. Okay? So we'll use x and y, but you should be versatile to use any symbols. But we'll use x and y. So how should we define variable x in this situation? What quantity does x mean? X is? Okay, there's nothing here about time. There's nothing here about time going by. Yeah. The amount of square feet the first painter. Okay, so if we say the amount of square feet that the first painter has already painted, is that constant or varying? Right. Okay, so x is square feet painted by, and we got P1, just to save space here, P1. Or the area painted by P1 in square feet. That'd be fine too. The area painted by painter 1 in square feet. So we'll write Y that way. Is the area painted by P2 in square feet. Both are synonymous, equivalent. Both have the units. That says painted. Okay, so what would delta x mean?
Change in square feet painted by.
The change in square feet painted by painter 1. What do you think? Yeah. The change in area. The change in area for painter 1. By P1 in square feet. So just for time's sake, the only difference between delta y and delta x is going to be now P, the other painter. Okay, so I'm using bars to help us make sense of this situation. It's a visual to help us make sense of this. So looking at the bars, how might I have chosen these bars? This top bar here. Okay, so is this P2? Is this bar P2? No, P2 is a person. P2 is a person. It's not a quantity. So what have we named this quantity? What have we named this value? And what have we named it? Y. We said Y was the number of square feet. So I'm saying the length of that bar is Y. The length of that bar is Y. And the length of this bar is X. So X and Y are variables. They take on values of the quantity, right? 10 square feet, 20 square feet, 100 square feet, 200 square feet. All right? So question is, does the amount painted by painter 2, or Y, does it change with constant rate of change with respect to the amount painted by painter 1, X? Are these in a constant rate of change relationship? I heard yes, I heard no, I heard we don't know yet. No. We don't know. All we know is that we just have one point. So imagine a graph. Imagine a graph of this. All we're given is this one point, that when X is 250, Y is 400. That's all we know. Okay, so I'm going to give you a little more information here. So here we are at, what, 250 corresponds to 400. So each one of these vertical bars obviously is 100. That's your reference to kind of make sense of this. So I'm going to say, all right, now painter number 1 it's really touchy. There we go. All right, so now painter number 1 has just painted a total of 450. Okay, so why? So notice that the new amount painted is thinner. What might I be represented by the fact that the bar is thinner? What am I representing by the thinner bar? And we call that delta x. So I have just showed you a delta x. And so now the new total value of x is what? The new total value of x. Total amount painted by painter X is now 450. It's now 450. Okay? What was that change? What change did we just see? Change of 200. Okay, so now I ask you again. Is the amount painted by painter 2 in a constant rate of change relationship with the amount painted by painter 1? Yes or no? I heard yes. We still don't know.
No, we don't.
We don't. Let's take a look at what could we do here. We could set up a table of values. Let's set up a table of values here. X and Y. And then let's look at X over Y. Okay, so we know that when X was 250, Y was 400. And when X was 450, what is Y? 500, 650. So I want for each of those, I want you to find the ratio, Y over X. I want you to find the ratio of Y over X for each of those. Go. What'd you get for the first one? Y over X? 1.6? And what'd you get for the second one? 1.4? Do these two quantities have a constant rate of change relationship? The amount painted by painter 2 with respect to the amount painted by painter 1? No, they don't. Is that, we have consensus on that? Not constant rate of change. What's that? Were you going to say something? Why not? He's saying there still could be a constant rate of change. So why does this not show it, and what would we need? And so can you be more specific? What trend are you looking at?
Like Y over X increased to 1.6.
Okay. So how about applying what we learned on Tuesday and in the homework? Were you going to say something?
You need delta Y over delta X.
It's about delta Y over delta X. Constant rate of change is about the ratio, the proportionality of changes in the quantities. It's not about the quantities themselves. And we talked long about this on Tuesday, right? We worked hard on this. And you worked hard in your homework. Constant rate of change is about proportionality of the changes in the quantities, not values of the quantities themselves. It's still, the jury is still out. We still don't know. Okay, here we go. Oh, so close. There we go. So now, what's the new? I'm going to, starting at 450, I just did another delta x, call this delta x1, a delta x2 of what? How much did it? An additional amount that painter 1 painted was 300, so the total amount painted is 750. Okay, now I want you to, I'm going to leave this up to you now. So what kind of analysis do you need to do to answer the question, is this constant rate of change or not? So go. So this is going to write. Everybody is writing. You're writing. What do you need to do to check this for constant rate of change? 750, 850, 950, 1,000, right? But then a quarter. 1025. Sitting back and watching.
Yeah, that's what I did. 750 on 450 is unfortunately.
What do you need here to solve this problem? What do you need to solve this problem? Answer this question. I don't know if that's going to work. 2 hours and not forget it all.
Well, you need to change this to 750. Yeah, I think you would do 750. Sadly, that gives me 6-7, so that's not fair. That's a race. That's 1.67, 1.6.
What do you need here? What do we need?
750 times, say, 537.
You need another table. Got to have another table setting up delta x and corresponding delta y's. That's the kind of initiative that you have to have. Okay? I can just sit there and do this whole thing and you can watch. You'd be like, oh yeah, I get that. But this is the kind of initiative you have to have. Okay, I need a constant ratio of delta y to delta x. So I need to check a bunch. So I'm going to build a table of delta x and delta y. And then look at the ratio. So what's one delta x and corresponding delta y that we have? It's the first one that we have. 200 and 250.
That would be 0.8.
And so No, but it's delta y to delta x. We're asking about y to x.
Oops,
Or,
my bad.
so that would be
1.25.
1.25. So it's 1.25. Do we have constant rate of change? You need, no, it needs to be always 1.25. That's the whole point. Constant rate of change, meaning the ratio, that quotient, the relative size of the change in y to the change in x has to be constant at 1.25. So we need to compare it. We need more. We need another delta x. What do we got? 300 and this should be 1025. So 375, I agree. Ratio is? Anybody have another? And how'd you get that?
Just like the total changes, like total.
Yeah. So she's saying, look, there's another delta x here, starting at 250 and going to all the way to 750. We can call that delta x3. And that'll correspond to 400 all the way to 1025. Or it should be right there. Okay. Delta y3. So what were the numbers? 500.
And 625.
625. Ratio.
1.25.
Does y change at a constant rate of change with respect to x?
Yes, it does.
It appears to, right? So now we have evidence that it's sure looking like it, okay? So we have evidence. Every ratio that we're taking ends up being the same value. Okay? And again, we're talking about comparing these two quantities. We're comparing these two quantities, and to test for constant rate of change, we look at the changes in those quantities, right? We look at the ratio of the changes. This can change, and that's okay. I mean, we do a 750 and 1025. We'll still get another ratio. It'll be something different. It won't be this. Doesn't matter. Okay. What matters is that y is changing at some rate that's constant relative to how x is changing. So we could say that y is changing. What? Y is changing. How is y changing with respect to x? How is painter 1 painting relative to painter 2? No, how is painter 2 painting relative to painter 1? 1.25 as much as. Or 1.2 times as fast. That's what the constant rate of change means. It means how fast y is changing with respect to x. Y is changing 1.2 times as fast as x. And that's a relative size, right? It's a relative size of the change in y to the change in x. Because that's the quotient. Yeah?
So the difference is changing something and then the actual values of the difference. That's the ratio. Like we have one table, we have a circle, that's a change ratio, and the other one's just going to be the ratio.
Yeah, this is total amount painted.
Okay.
Total amount painted at any given time. And then this is corresponding changes in total amount painted. It's the changes, the relative size of the changes. If that stays constant, then you have constant rate of change. And that should be very familiar with Tuesday and your homework. So your homework was all about that. Your homework was all about that. Yeah.
So we have a problem like this. We essentially have to ignore how they got to that first initial value after we started measuring this. Because if they are at a constant rate of change, how would it ever get to 400 or 250?
Good. So let's just put that on hold. So yeah. So he's kind of looking backwards and saying, oh, something's up when you go backwards. But as far as we know, starting at that value and moving forward, we've got constant rate of change. Other questions? That's good. We'll get to it. Yeah. Just picking it off the scale. This was 700, 800, 900, 1,000, and it's a quarter of the way. Is it? Okay. Other questions? Okay. If we knew a change, so now if I told you that painter X painted 75 more square feet, how much more did painter 2 paint? Talk to the person next to you. Represent it mathematically, not just the answer. Represent it mathematically. How much more did painter 2 paint? Represent it with an equation. Okay, so if we know a change in X, say painter 1 paints 75 more square feet, then how do we represent what painter 2, the additional amount that painter 2 paints? This is huge. This is huge. Yeah?
So we know that delta y is equal to the constant, which is 1.25 times delta x
That's it. Just stop right there. There you got it. So it's 1.25 times
times 75.
delta y equals k delta x. K delta x. Delta y equals k delta x. If this is the relative size of the amount painted by painter 2 to painter 1, then if painter 2 paints 75, then painter 2 paints that much of 75. So it's multiplication. He's going to paint 1.25 as much as painter 1 did, or as much as 75. Or delta y equals k delta x. I'm emphasizing it because that may be the biggest idea of the whole semester, you could argue. Delta y equals k delta x. Given a change in your input quantity, if you have constant rate of change, the change in the output is k times delta x, where k is the value of the constant rate, or in this case 1.25. Okay, so again, the two mathematical results of constant rate, delta y over delta x equals k, and we solved for it here. And then, given a change in x, the delta y would be k delta x. And then if the variables were different, if you had d and t, could you do the same thing? It'd be delta d over delta t is a constant. And delta d equals k delta t. Okay? No difference, you're just changing the symbols. Okay, any questions before we move on? Okay, so remember, what did we say? We said that to graph in the xy plane, what do we do? How do we graph in the xy plane? So which was our x coordinate was down here? I put x here, right? Please tell me I put x here. Good, okay, and then y here. So in the xy plane, x is the distance measured horizontally, and then y is measured vertically. So we need to flip it up, right? And then, again, they're going to change together. So that's really dark, but the idea. And then this will be any given x and y taken together. That's our point. So all the points then shouldn't. All the points, we got constant rate of change, they're going to form a line. Okay, they're going to form a line. All right, so let's look at that. So here's another same thing, another view of that. So if you track the x and y points together, okay, it makes a line. So constant rate of change. Okay, so let's talk about lines here. So you probably in the past you've learned mx plus b. Find the value of m, find the value of b, plug it into mx plus b, and move on to the next problem. Okay, so we're going to do something different. You can't just say, because I know mx plus b, I don't have to pay attention to this. This is crucial. So the type of stuff we're going to do is crucial in terms of your thinking and having, again, more tools in your toolbox. Okay? So what I'm going to do is look at here we are at the start. The starting value was 250 and 400, right? So I'm going to do a change of x of 50. So how can I represent that change? So here I was at 250, 400. How do I represent the change of x of 50? Which way? Up, down, left, or right? To the right, right? So that right there is a delta x of 50. So if I started at 250, what would that? This was the point 250, 400. Okay, so here we go. Delta x just changed by 50. What's the corresponding delta y? Apply what we learned. Delta y equals 1.25 times 50. K delta x. Painter 2 is always painting 1.25 times as much as painter 1. K delta x. You got 62.5? So now look, what was the starting value? Here's the initial value of painter 2. And this was the change in the amount painted by painter 2. So now what's the new amount painted by painter 2? 400 was the initial. And the additional amount is 62.5. So now painter 2 has painted for 62.5. So the new value of y equals the old value of y plus the little change in y. So that new point is 300 and the old y plus the change in y, 462.5. That's this point right here. Okay, so later on, here we are at another place here, 450 and 650. We're going to do it again now. So 450, 650 is, so painter 1's painted 450 total, painter 2's painted 650 total, and say painter 1 comes along and paints 150 additional. And we can show that here. Delta x is 150 additional. So I want you to do the same process that we just did. Find the corresponding change in y, and find the new value of y, and then plot the new point. Find the corresponding change in y, find the new total value of y, and then plot the new point. If painter 1 paints 150 more, starting at 450.
Well, painter 1 painted 150 more, so you multiply that by 1.25. Find how much payment 2 paid for because I wasn't paying 1.25 times as much. So you do 150 times 1.25.
So 187 plus.
Okay, let's see who's on top of it. How about right here in the glasses? Yeah, great sweatshirt. Talk me through it. So what'd you do first? Sorry, hold on a sec. You can whisper. Keep whispering. You can keep going. Whisper. Nice and loud. He wants 1.25 times 150. What do we think? K delta X. And what'd you get for that? 187.5. So, when painter 1 paints an additional 150, painter 2 paints an additional 187.5. Keep going, you're doing great. Add. He said he added that to 650 to get the final Y value. So before painter 2 had painted 650, we just calculated the change in Y, add them together to get. And what's the new amount painted by painter 1?
Is it X is 600?
450 plus the change.
So 600.
600. And then the new amount, total amount by painter 2, 650.
837.
So let's watch it happen. Ready? Here it goes. So here goes painter 1. As painter 1 paints another additional 150, painter 2 paints an additional 187.5. So now the combined totals are 600 for painter 1, 837.5 square feet for painter 2. Okay, one more time.
I agree.
Any questions? Anybody have a question? This process is super important. Let's start at 750. Let's do a change of 200. So X is going to change by 200. Go.
750. 200.
So this is the point, what? 750, 1025 that we had before? Delta X is 200. Go. Isn't it 250?
Sorry. If it goes from 600
I'm doing 750 to 950.
Yeah. So
Oh, it looks like a 7 after.
This is 750, and then I'm going to do delta X of 200 to get to 950.
Oh, okay. I'm sorry.
Does it work?
Yeah, I'm just.
I was like, I could be wrong, so
No,
I'll make sure.
I'm confused. I'm sorry.
It's okay.
I'm sorry.
No problem. Okay, so here we are. Painter 1 has painted 750 square feet. Painter 2 has painted 1025 square feet. Now Painter 1 is going to paint an additional 200. So let's go with someone here. How about, let's see, way in the back row. Sorry, I forgot. Walden. Did I get it? Walden, yes. Tell me. Nice and loud. Okay. And what do you get when you do that? So we're going to take the change in Y is going to be 1.25 times the change in X, 200. And what do you get when you do that? Is it 250? 1, 2. Then what? And so the new total is? $1,275. The new value of y equals the old value of y plus the change in y. It should make perfect sense. There should be like that should be like butter, like falling out of bed. You start with a value, you add the change, you get the new value. But it's a very important idea, okay? That the new value of y, painter 2, is the old value, 1025, plus how much additional he painted? 250 to get to 1275. Is it right? Oh, my dot's too high. Okay, I'm just too high. I'm up on the line, it should be there. Okay, so now we're going to repeat this again. We're going to repeat the same process. Let's start from this point. What was the coordinates of this point? 450 and
650.
So here, in my experience, teaching both pre-calc and calc, this next thing I'm about to do, it's very difficult to get it to stick with students. So turn on your attention 150% and try to retain this. We'll practice it, but try to retain it. Don't forget this. So what do we do first? We took a change in x, right? And then we got the change in y by applying constant rate of change. Delta y equals k delta x. And then we wrote the new y was okay, so now the difference here is I'm just going to pick any point, so forget about the numbers. This point I'm going to draw right here could be any point on the line. I'm going to call it x, y. I could have picked this one. I could have picked this. It represents any and every point on the line. Don't tune out. Here we go. It represents every and any point on the line. So I'm starting at 450, and I'm going to start with my change in x. And that is terminating at any or every point x on the line. So how would I write the expression for delta x? So what was the change in x starting at 450 and ending at just arbitrarily x, any x? Final value minus initial. X minus 450. Does it make sense? That point, xy, could be any point I want. And so it represents every point on the line. Okay? What do we do next? Change in y. Next is, what will the corresponding change in y be?
Minus initial.
Nope, use constant rate of change.
A times
Times x minus 450.
All right, so delta y is, and what is k? 1.25 is our k, times x minus 450. Does it make sense?
does now.
1.25 delta x is always what the corresponding delta y is. Finally, what are we after? This is like the new y, right? This is like the new y. And the new y equals old y. Old y plus change in y. So here we go. Y equals, old y is 650. Okay, so mx plus b just took a back seat, okay? It just took a back seat to this. Much more powerful, much more applicable, and it has meaning, right? Because what is this? This now represents every point on the line. Every point on the line, okay? And we know what every part means. We start with a change in x, starting from 450. the change in x to any other point is x minus 450. The corresponding change in y is 1.25 times the change in x. There's that right there is the change in y. To get the new value of y, of our point, add the old y plus the change in y. So this is called the point slope form. So you should be able to go through that process with a different application and a different starting point and a different constant rate of change. You should be able to build the equation of the line the same way. It's point slope form. So when you're doing your homework and when you get to the section 3 of module 2, it's all about building and using this form. Okay, so a question was asked about what's happening before. So what happened before? Was it constant rate of change before? So let's just assume that it was. So what can we do? We can do the same thing again. I'll do it in red. So here we are at 456.50. Or this point is what? What was this point? 250,
250 and 6.
400. Let's figure out what's happening when painter 1 starts. When painter 1 is at 0, let's figure out what's happening. So what's our change in x? So we're starting at 250. Now we're going to go this way to back to where he painted none. What change in x is that?
Minus 250.
Negative 250. It's like we're going back to the point where he hadn't painted anything. So that's like changing the amount painted by negative 250. What's the corresponding change in y?
Negative 250 times
1.25 times negative 250. Tell me how much that is. 2.5. What is it? Same. We're doing the same process now. We got that change. New y equals old y plus change in y. What was the old y? 400 plus the change in y. What do you get? Old y, 400 plus the change in y, negative 312.5. 87.5. So what's going on here? So assuming that it was constant rate of change the whole time, we just got this point 0, 87.5. What does it mean? Who? Yeah.
The
Painter 2
had already painted.
had already painted when painter 1 started. So painter 2 had done a little bit, 87.5 square feet, and then painter 1 started, and then they were painting together from there. Okay? Does that answer it? Okay.
That's why it's
Now, if we were to solve this out, so if we were to take this equation right here and then do the algebra, 650 plus 1.25 x minus, what is this? 1.25 times 450. 100. Say it again.
562.5.
Thank you. And what do you get? Y equals 1.25x minus 87.5. mx plus b. M is the constant rate of change, or the slope. B is the y-intercept, which we found before, right? We found it using our process here. We found it to be 87.5, so there it is. Plus. Thank you. Plus. So with the point slope form, you can multiply everything out and simplify it, and you get mx plus b. And that's fine. That's okay. You know, mx plus b is legitimate. Just know what it's about. It's about the constant rate of change is the slope. And then your y-intercept would be the value of your y quantity when the x quantity is 0. The value of your y quantity when the x quantity is 0, which we got over there.
so
Okay, start studying for the test Wednesday this weekend.